Hello everyone, my name is Leena, currently studying BTech in JNTU Anantapuram in Computer Science and Engineering. As a part of assignment, now I am here to discuss about the topic double-ended queue. In short form, it is also called as dequeue, where we can perform the insertion and deletion operations from the both ends. Coming to the dequeues, let us know why there is a need to use the dequeues. Programmers mostly use queues for task scheduling, handling requests, etc. Stacks for undo operations, recursion management, etc. But sometimes you need both stack and queue behavior together. Sometimes you need fast access to both the front and back of a collection. Traditional arrays or linked lists either weren't fast enough or were too clumsy for this. That's where dequeues become very important. These queues combine queue and stack functionalities into a single powerful structure. Let us know why we use dequeues. Dequeues are also known as double-ended queues are often preferred over regular queues because they were more flexible. The flexibility of the dequeues. Dequeues are more flexible than regular queues, allowing for both first in first out and last in last out operations where we can perform in the stacks and queues. In a queue, you can only add to the rear end and remove from the front. First in first out operation. In a stack, you can only add to the rear and remove from the rear. Last in first out operation. In a dequeue, you can add or remove elements from the both ends efficiently. Both front and back operations are fast. Let us know what is meant by dequeue. Dequeue is a more generalized version of linear queue. As you know, the linear queue has some restrictions while performing the insertion and deletion of elements, but in dequeue, you can only perform both insertion and deletion operations at both of its ends. That's why it is called a double-ended queue. Here is a visual representation that we can insert and delete operations from the both ends. Let us know about the types of queues. In data structure, there are two types of dequeues which are created by restricting certain operations. Let's clearly understand them. The first one is input restricted queue. It is a dequeue with some limitations while performing insertion operations. In the input restricted dequeue, it will perform the deletion at both ends, whereas it performs the insertion at only one end. The image below shows how input restricted dequeue limits insertion at one end. Here is the visual representation that deletion can be performed at both ends and insertion can be only performed from one end. Next one is output restricted dequeue. It is a dequeue with some limitations while performing deletion operation. In the output restricted dequeue, it will perform the insertion at both ends, whereas it performs the deletion of elements at only one end. The image below shows how output restricted dequeue limits removal at one end. Let us know what are the operations we can perform on dequeue. Four basic operations are performed on dequeue. They are as follows: insertion at rear, insertion at front, deletion at front, and deletion at rear. Along with these primary operations, you can also perform isEmpty, isFull, and peek operations. These operations are called supportive queue operations. The time required to implement all these functions must be constant. The time complexity of dequeues is order of 1.